Since thread forms, stocks, dies, taps, as well as internal and external thread cutting are all well covered in Caris Media Productions thread and thread cutting, we won't be going over them again here, but rather concentrating on removing broken screws and studs and thread repair. At some time, it's inevitable you'll have to remove a broken screw or stud. There are two common methods of removing a broken screw or stud: stud removers and screw extractors, easy outs. Place the stud remover over the broken stud, then turn the base clockwise to lock onto the top of the stud. Then, using a Tommy bar, rotate the stud remover in an anti-clockwise direction. Drill a hole in the top of the broken screw or stud to the recommended diameter, just deep enough to stop the extractor from reaching the bottom when it's gripped. Too deep and it could spread the metal and make it tighter. There are charts available to tell you what size to use. Then, using a tap wrench, turn the extractor in an anti-clockwise direction. It takes a quick and positive grip, feeds itself into the hole, and should start the most stubborn bolt or stud and turn it out on its own thread, leaving the original thread in the hole undamaged. Obviously, external and internal threads need different methods of repair. Unfortunately, there's no easy method of repairing external thread. If the screw or stud's only slightly damaged, you can use a die nut or die to clean it up. This removes the shaggy, damaged bits and gives a clean thread again. If the part that's threaded is badly damaged, expensive or irreplaceable, it might be possible to build up the metal by metal spraying or build up a new layer of metal by welding. Neither is cheap or easy, and they're not recommended. Fortunately, this situation is rare, and what you'd usually do is replace the screw or stud with a new one. On the other hand, damaged internal threads are often part of expensive machinery castings and will need repairing. Now, the easiest thing to do is to drill a larger hole and thread that. Fine if there's enough metal around the damaged thread and the size of the screw or stud isn't crucial. A solid bush insert has internal and external threads, both standard thread sizes. Solid bush inserts are used where there is serious damage or bad bell mouthing of the hole, and a wire insert won't provide enough support. The damaged thread is drilled out, and standard dies are used to tap the hole to suit the external thread of the solid bush insert. The solid bush insert's fitted using chemical compounds or a key to prevent it coming out. Solid bush inserts can also be used to reduce the thread diameter if desired. They have the advantage of using the standard dies present in every workshop. Coiled wire inserts come in two types. This one's a free running insert. They're generally made from stainless steel, cold rolled into a diamond shape from round wire. They've got a tensile strength greater than 1.3 gigapascals. After being rolled, they're spirally wound like a spring and cut to length. Standard lengths are a multiple of the diameter, so a 10mm diameter insert will be available in one diameter, 10mm. 2D, 20mm, 3D, 30mm, and so on. A 15mm diameter insert will come in lengths of 1D, 15mm, 2D, 30mm, and so on. Choose the one that's the closest fit for the job. The obvious difference with a locking insert is the flats in the centre coils. These flats reduce the internal diameter of the insert. As the screw winds into the thread, it forces the flats out. Since there's really nowhere for them to go, they grip back on the fastener. You can actually use them to make a lock nut if you want to. Obviously, thread inserts are corrosion and heat resistant. The advantages of coiled wire inserts are they have a self-locking action because the coils spring back against the fastener. As the torque on a thread increases, it improves the locking action. They distribute the load over a greater diameter and the full length of the thread, which improves the strength of the fastener. And they're corrosion and heat resistant. Installing a thread insert is a 4-stage process. Drilling the hole, tapping the hole, installing the insert, and breaking off the tang. Thread inserts need special oversized taps, although they have the same pitch as the screw or stud to be installed. Like all taps, they are made in taper, intermediate, and plug or bottoming. There are also pilot nose, spiral point, and spiral flute taps available for improved swarf control. You're also going to need a thread insert tool. The slot drives the tang on the insert and winds it in. The tool can also be used to break off the tang after installation. After the hole's drilled, tap it with the right screw thread insert tap. Don't use normal taps. Use a bottoming tap to finish to the bottom of the hole. Select the right sized insert and put it on the thread insert tool with a tang at the bottom. Wind it onto the thread until it finishes about 1/2 of a turn below the surface. You can remove it at any time if there's a problem or you want to check your progress. Don't twist the tang off or you'll damage the tool. If you wind the insert right to the bottom of a blind hole, you usually won't have to remove the tang. There are some situations where the tang needs to be removed from the hole, so use a pair of long nose pliers. Push the tang down and then pull it back sharply and remove. Well, that's it for this section and the tape. No cheering. Review any sections you aren't sure about and then do the thread cutting exercises.